Okay, welcome. This is going to be Chapter 5 test review. So I'm going to go over some of the problems, and I will link the page or the worksheet down below in the comments or in the description of the video. I first want to talk about, like, if I'm talking too fast in this video, we can slow it down. If you come to settings here and go to speed, you can go half speed. Or if I'm talking too slow for some of you, we can speed it up, okay? So I'm going to try to go through this in a short amount of time. So if you need to slow it down to watch a little bit better, you can. Okay, so number one is solving an absolute value. So we'll solve, we have x squared minus 9 equals 10. Okay, in order to split up my absolute value, we're going to take the positive, and we're also going to take the negative answer to that, because what's in the absolute value can both be positive and negative to give me 10. So I'll have x squared minus 9 equals 10. Subtract 9, or sorry, add 9 plus 9. X squared equals 19. And then square root, you get x equals plus minus radical 19. Here we'll have negative x squared plus 9 equals 10. Subtract 9, negative x squared equals 1. We'll divide by minus 1. And you get x squared to be negative 1, square root of that, you get x to be plus minus I, which we know we can't have, but I still want all the answers. Okay, number 2 says to divide, and it gives you that polynomial there. So we'll use synthetic division. We'll put negative 2 out front. And notice it's not in order. So we got to go 17, 0, minus 4, 0, 2, minus 10. Okay, so we'll bring down 17. We'll multiply by 2 and get negative 34. We'll add. We'll multiply by 2 and get 68. We'll add to get 64. We'll multiply to get negative 128. Add. We'll multiply again to get 256. Add, you get 258. Multiply, you get negative 516. And add one more time, you get negative 526. This last number is your remainder. You have constant x, x squared, x to the third, x to the fourth. So you have 17 x to the fourth minus 34 x to the third plus 64 x squared minus 128 x plus 258 plus negative 526 over x plus 2. Okay, number 3 says give a polynomial with zeros, and it says your zeros are 1. You have 0 of negative 2 with multiplicity of 2, so it appears twice. And you have I. So if I is a 0, negative I is also a 0. So we have x minus 1, x plus 2, x plus 2, x minus I, and x plus I. Okay, so now we just need to FOIL and multiply everything out. So we'll have x minus 1. If I FOIL this, I'll get x squared plus 4x plus 4. When I multiply this out, I'll do that over here, kind of the long way. You get x squared plus xi minus I squared. Now your xi and xi cancel. So you have x squared. And I squared is negative 1. So you have minus negative 1, which becomes a plus 1. So you have plus 1 there. And you keep going. So FOIL these two or distribute. You've got x to the third plus 4x squared plus 4x minus x squared minus 4x minus 4 x squared plus 1. Combine like terms, so this one and this one cancel. So you'll have x to the third plus 3x squared minus 4 x squared plus 1. So you have x to the fifth plus 3x to the fourth minus 4x squared plus x to the third plus 3x squared minus 4. And then combine like terms. So x to the fifth plus 3x to the fourth plus x to the third minus x squared minus 4. And there you go. All right, so now question number 4 says solve. So you got the square root of 3y minus 2 equals 3 minus the square root of 3y plus 1. All right, in order to get rid of the radical, you need to isolate it first and then square both sides. So I get 3y minus 2 equals, when I square this side, I can do the shorthand. We'll square the first term and get 9. We'll multiply all three terms together. So you got 3 times negative radical 3y plus 1 times 2. So that's a minus 6 radical 3y plus 1. And then you square the last term. So we're squaring this radical. So plus 3y plus 1. If you can't figure that out, this square just tells you to FOIL it together or multiply it by itself. So you can do that, and you can do first outside, inside, last. Okay, notice I still have a radical left, so we're going to isolate it. So minus 3y, those cancel. Minus 9, minus 1, minus 1. Cancel, cancel. So you get minus 12 equals minus 6 radical 3y plus 1. Divide by negative 6. You get 2 equals radical 3y plus 1. Okay, so now my radical is isolated. We'll square both sides. You get 4 equals 3y plus 1. Well, minus 1, 3 equals 3y, and y equals 1. We always need to go back and check this with the original problem. So the original problem was 3y minus 2 square root equals 3 minus 3 square root 3y plus 1. So just plug in 1. So I got 3 times 1 is 3 minus 2 is 1. The square root of 1 is 1. 3 times 1 is 3 plus 1 is 4. Square root of 4 is 2. 3 minus 2 is also 1. So it does check out. Okay, find an equation perpendicular to 4x plus 3y equals 6, and it goes through 0.76. So the first thing we want to do is find out what my slope is. So we'll subtract 4x. So those cancel and we'll divide by 3. So I have y equals negative 4/3 x plus 2. Now, since I want perpendicular, my slope is a negative reciprocal. If I wanted parallel, I'd have the same slope. So my new line will be y equals 3/4. So you change the sign and you flip it over. X plus b. I don't know what b is. B could be 2, but I don't know. So now to find b, we are going to take and plug in this ordered pair. So I have 6 equals 3/4, 7 plus b. So I have 6 equals 21/4 plus b, and I'll subtract 21/4 minus 21 over 4. Change the 6 so that it has a denominator of 4, which is 24. So you get 24 fourths minus 21 fourths, which will be 3/4. So your equation will be y equals 3/4 x plus 3/4. All right, so that was kind of some older stuff from semester 1. Semester 2, or this chapter 5 stuff, we will first look at, so we want to graph, give domain and range, and tell what happened to the parent function. And we'll start with f of x equals -2 log x minus 1 plus 3. Okay, we'll start with the parent function is log of x. And we go down our letters, H, B, A, K. So H is the -1. So it goes right 1. B, there isn't one. That'd be this number right here. A is -2. So that is a vertical stretch by 2. And it goes over, it flips over the x-axis. And K is +3. So that is up 3. We also want domain and range. So my domain, so this inside here, this x minus 1, has to be bigger than 0. Okay, that's the definition of a log. So x has to be bigger than 1. So that is 1 to infinity. Range, the range for logs is always minus infinity to infinity. So now when we graph this out, okay, we can use the graphing calculator and kind of just check. So -2 log x minus 1 plus 3. And we'll get a general idea of what it looks like. So it looks something like this. And this goes on forever, and this goes on forever. Even though it looks like it may stop on your calculator, my range is -infinity to infinity. And with these, I'm just wanting a rough sketch, so it doesn't have to be perfect. So the next one is g of x equals -1/2 x minus 3 plus 5. Okay, so again, we'll start with parent function. My parent function is 1/2 to the x, so that's exponential decay. So we start off with this right here. Okay, so then we do h, b, a, k. H is -3, so that goes right 3. B, I don't have one again. A is just -1, so that's over the x-axis, and k is +5, so that is up 5. Okay, we need domain and range. Domain for exponentials is always -infinity to infinity, which is the range for logarithms. Now, the range on this one might be a little bit tricky. Okay, so if we go back to our parent function, we moved it right 3, so this goes right 3. So now we might be over here somewhere. Okay, it went over the x, so now let's say we're here. Okay, and we moved it up 5, so we're sitting maybe right about here somewhere. I don't know exactly where it crosses y-axis. Okay, so I had a horizontal asymptote at 0, and it moved up 5. So looking at this, the highest number I can pick is 5, and I can pick anything below that. So we'll say -infinity to 5 in parentheses, because I can't actually choose either one of those. Okay, we want to expand. We want to expand log base 3 of rs squared, that's a square, over 3t. So I expand division with subtraction. So I have log base 3 of rs squared minus log base 3 of 3t. Now I'll split this multiplication up with addition. So log base 3 of r plus log base 3 of s squared minus log base 3 of 3 plus log base 3 of t. Now I put this in parentheses because this negative goes to both the 3 and the t because they're both on bottom. So this one, nothing more. The 2 on this one comes out front because it's an exponent. And I distribute this negative, but also log base 3 of 3 cancels, and that becomes 1 minus log 3t. Now we've got some solving ones we want to look at. So I'll say log base 3 of x plus 2 equals 4. Since the log's on one side, we'll just rewrite it as exponential. So I have 3 to the 4th equals x plus 2. 3 to the 4th is 81 equals x plus 2. Minus 2 on both sides, you get x equals 79. And we want to check that. We'll plug in 79. 79 plus 2 is 81, which is a positive number. So we're good. The only problem would be if I had 0 or a negative number. All right, so 9 to the x equals 3 to the x squared minus 4x. So here my bases can be made the same. So 9 is 3 squared. I already had the exponent up here, so I'll multiply those together. Equals 3x squared minus 4x. Since my bases are the same, they cancel. And we'll say 2x equals x squared minus 4x. And then it's a quadratic, so we got to set it equal to 0. So 0 equals x squared minus 6x. Factor out an x minus 6. And so x is 0. Check those. So I'll have 9 to the 0 is 1. And I get 0 minus 0. So 3 to the 0 is also 1. So 0 checks. And we want 9 to the 6th equals 3 to the 36 minus 24, which is 12. So 9 to the 6th. 9 to the 6 is 5, 3, 1, 4, 4, 1. And 3 to the 12th is also 5, 3, 1, 4, 4, 1. So they both check. So we're good. Now this next problem, I wrote a little bit wrong on the paper. I wanted to write this, log base 3, 7 minus 2x minus log base 3 of x plus 2 equals 2. Okay, so I got to combine these two, and I'll combine them with division. So 7 minus 2x, x plus 2 equals 2. Now, since my log's on one side, we'll rewrite it as exponential. Okay, so this becomes 9. We'll multiply the whole thing by x plus 2. So I have 9 x plus 2 equals 7 minus 2x. And I get 9x plus 18 equals 7 minus 2x plus 2x plus 2x minus 18. Minus 18. So I get 11x equals minus 11. X is negative 1. Again, you need to check that. So I have 7 minus 2 times negative 1, which is positive 2. So that's 9. And then negative 1 plus 2 is 1. So that's positive. So that's also good. So it checks out. Now the next two, we have log base 5 of 1/2 equals x. And we have e to the minus 3 ln of 6. Okay, all you got to do is put these into the calculator. This one you might have to use the change of base formula over log of 5. Okay, and put that into the calculator. This one you're just going to put into the calculator just the way it is, making sure that this exponent's all in parentheses. Okay, word problems. Carbon-14 has a half-life of 5,730 years. What equation would model this? How long would it take to take 100 grams to 40 grams? How much of 100 grams would be left after 2015 years? Okay, so my equation, part A would be P equals P0. So your ending amount equals your start amount times a half raised to the time over 5,730 years. Okay, that should be known. I've written that on the board a couple times. You just got to plug in these two numbers. So part B says, how long does it take to go from 100, so P0 is 100, down to 40 grams? Okay, so I got to solve for T. So first thing we're going to do is divide by 100. So you get 2/5 equals 1/2 to the T over 5,730. Now to get rid of my base of a half, we got to take the log of the same base. So we'll take log base a half. So I get log base a half of 2/5 equals T over 5,730. And then we'll multiply by 5,730 to get T all by itself. And again, we just got to put this into the calculator, probably using change of base formula. So 5,730 log of 2/5 divided by log of 1/2. And I get time to be 7574.65 years. So that's how long it takes to go from 100 grams to 40 grams. Okay, so now part C says, how much is left after 2015 years? So I want to know what's left. If I start with 100 grams of my half-life, 2015 to 5,730. Okay, all you got to do is put it into the calculator. Be very careful about it. So 100, the half raised to the 2015 over 5,730. So you get 78.37 grams is left. Okay, the number of people infected by a virus is given by, and they give you the formula where T is the time in days. And how many days will 1,000 people be infected? So we're going to start, N is 1,000, and we got 2,000 over 1 plus 3 e to the minus 0.4 t. We'll multiply the whole thing by 1 plus 3 e to the minus 0.4 t. So I have 1,000. I have 1,000 times 1 plus 3 e to the minus 0.4 t equals 2,000. We'll divide by 1,000. Divide by 1,000 on both sides. So you have 1 plus 3e to the minus 0.4 t equals 2. Minus 1, 3e to the minus 0.4 t equals 1. Divide by 3. And I'm going to come up here. E to the minus 0.4 t equals 1/3. Now to get rid of my base e, we're going to take the ln of both sides. So those cancel. You get minus 0.4 t equals ln of 1/3. And then the last step will be divide by negative 0.4. Okay, so we'll get ln 1/3, just typing it into your calculator, divided by negative 0.4. And you'll get t to be 2.75 days in this case. Make sure we have a label on these. All right, last one. So if $5,000 is invested at a rate of 6% a year, compounded quarterly, what is the amount in the account after 8 years, and how long until $10,000 is in the account? So we'll use this equation, A equals P1 plus R over N in T. So I'm putting in $5,000. The interest rate is 6%, so that's 0.06. It's compounded quarterly, so that is 4 quarters in a year. And I want to know after 8 years what is left. So all we have to do is put this into the equation and see what or put this into the calculator to see what we get. So make sure you're careful when you type this in, using extra parentheses when you need to. And you will get out $8,051.62. Okay, and the next part of that says, how long until I have 10,000? So I'm trying to double my money here. So this time I'm solving for t. So we'll divide by 5,000. If we divide by 5,000, we get 2 equals 1 plus 0.064 for t. Then we'll figure out what this number is. Just put it into the calculator, and we'll get 1.015 to the 4t. Now to get rid of this base, we're going to take it to the log of that same base. Okay, so these will cancel. We'll get log of 1.015 of 2, so that's your base, 4t. So then we'll divide by 4, and t will be, so log, probably have to use the change of base formula on that. So log of 2 over log of 1.015 divided by 4. We'll get 11.34 years. So he's got to leave that money in his account for 11.64 years. So that's the end of the review. As always, thanks for watching. This is at THS Mr. Jones, signing off.